Hello. What I want to do in this video is show you what you've been given, which is Earth orbit, which does what we see here. And we're going to compare that to a version that has all the bells and whistles. And you're going to be trying to add some of those throughout the week. All right. And I want you to wrestle with these, the coding. I don't want you to just find out what somebody else did. I want you to figure it out through watching this video series and perhaps even looking at other code that you've used in the past. Okay, so you can see in this, it's kind of mundane. We have just a circle representing the Earth, all right? And then we have a little satellite going around it, and then we have a little time counter in the upper right-hand corner, okay? So in this code, the way we made the Earth was we literally just made angles. This could be theta, but we have angles going from 0 to 2 pi, and we have 50 points around the edge of the circle. We give the X and Y coordinates of those points in line 20 and 21, just using some basic trig. All right, and you'll see when the plot statement comes up, down here near the end, we always plot those XE, YE points in blue, and we make it a little thicker with a line width of 2, just to make it look a little bit fancier. And then we're going to plot where the satellite is in a separate line of code, where we don't make it thicker. So we have that right there. Now, how do we get the satellite points? Those were the points that were calculated in the time step loop. Okay. Oh, and do make sure that in your code you've made the correction that this should be if X of IT is less than 0. I believe it's at less than 1 in the code that was given to you. That means if we're in the second or third quadrant, the angle given by the arctan right here isn't going to be correct. We need to add pi to it in order to fix it. So this should be if X of IT is less than 0, which will put us in the second or third quadrant. Okay, now continuing to look at this, how did we get this counter in the upper right-hand corner? Well, that's a text command. You can see down in the plot, there's a text command. We haven't used those yet this year, but what you see in a text command is the first thing is the X coordinate of where the text will be printed. The second thing in the command is the Y coordinate where it will be printed. Okay, and then the third thing is what we're actually going to print. Okay, so we're printing the time at this X coordinate and this Y coordinate. All right, so that might be one of the things that you're going to want to develop as you do fancier code. Okay, moving along. What you're ultimately going to want, if you can get everything, are the features that I have in this code right here. Much nicer, much nicer. Okay, we can see what's going on. Okay, so one of the things that we'll add, this is a relatively easy thing, we've done this in other code, is a trail for the satellite. Okay, so we'll have a trail as the satellite goes around so we can see the path that it's been on. Okay, and we want to compare that to a circle, which was sort of its starting circle. Okay, so we'll need to add a starting circle. That's these blue dashed lines. So we can see here the satellite clearly went outside of the starting circle as time went on. And we want to be able to visually see that, right? Another feature on here is we have this rotating radial line of the Earth. Okay, and that should rotate with exactly a 24-hour period, right? So we probably want to do it in seconds, but convert 24 hours into seconds and figure out the period of rotation. So to do that, there's going to be, it's almost like we have another little satellite here that's traveling exactly, you want another point on the edge of the circle that's traveling around in exactly 1 day. and we'll just connect the center out to that point to make it rotate. Okay, so that's the trick with that, is for create another point like the satellite point, but it's going to travel at the Earth's radius in exactly 1 day. So in the retrograde motion code that we're going to work with, you'll see something similar to that in order to get that radial line. Okay, other features up here, the time, instead of just being a number printed out, we have a concatenated string to give us the time. All right, and then a fancy thing that's a little bit harder is to convert that into a clock with hours and minutes here at the bottom of the screen. Okay, so that kind of clock is how we more traditionally keep track of the time. And that's tricky because clocks are base 60. Every 60 seconds gives us a minute, and every 60 minutes gives us another hour. So the conversion from time in seconds to clock time is a little tricky, something that you can figure out though. All right, so those are the added features that I have and that you're going to want to try to get into your code.